My name is Daniel Rieck. I run the cross-product integration team, systems engineering at Red Hat Engineering.
I'm Lars Hermann. I run the product and business strategy team for Red Hat. And we're going to do a role play here. So in case you get confused who is who, the guy with the blue shirt and the German accent, that's me, Lars. All right, let's get going. The topic for today is application-centric packaging with Linux containers and Docker. And before we dive into this, I wanted to actually understand who we have in the audience here. So we put up a slide with typical roles in enterprise IT as we knew it for a long time. Developers, application owners, lines of business on the left side, sysadmin, infrastructure owners on the right side. Would you guys mind maybe everybody with a developer type title moving over to this side and everybody with a sysadmin? Okay, but maybe raising hands. Who of you is more on the developer side of that slide? All right, that's quite a few. Test who's on the sysadmin side of things. Oh, that's a bit more. All right. Who's already in the DevOps side of things? All right, that's not too bad. Okay, maybe we get more of you over there. Okay, so what we wanted to do here, to maybe not bore you too much with all the technical detail, but also entertain you a little bit while you're waiting for your beer, is actually use our time machine, our patented Red Hat time machine, and travel back in time to how things were just a couple years ago, maybe 10. So if you remember, 10, 15 years ago, we were running a traditional application deployment, as we would call it now. Applications were running on actual hardware. There was a single user space deployed horizontally at massive scale. Typically the operating system or maybe a middleware stack was taking that on. And there were effectively two roles, right? There were the people with the application and there were the people with the infrastructure. And we would want to just go through a bit of a role play to illustrate how that went. So for the purpose of the role play, I'm going to be the application owner because I'm very much used to telling Daniel what to do. And you will probably be the infrastructure guy then, right?
You can call him Punch and me Judy.
All right. Feel free to do that later. All right, good. So let's go back to this time. Again, massively deployed environments, automated, managed. So here am I as an application owner. I have a developer team standing by to develop an application that will make all of us billionaires just a couple years down the road. Okay, Daniel, I need a couple servers for my development team to start.
I would need to buy hardware, right? So I'd say about like 3 to 4 months.
3 to 4 months. That's actually not too bad. Could be a lot worse. All right. Now my developers tell me that they have that particular library that they want to build on, and they tell me it's not in your standard build of RHEL that you're using.
Yeah, no problem. I think we're going to get in the next update. I think that's in 6 months or so. We just rolled on the last one. So, but you know, you're using the other version that is not compatible. How long until you get all your applications on the new version?
All my applications, you mean? I'm just talking about this one application.
Yeah, but you know, if you update, you can't have it both ways. If you update the library, then everyone is going to use it. You at least need to revalidate that it doesn't break. Okay,
maybe I ask my developers if they really, really need this library. So then, now I've checked all this out, so I want to roll it out. How long do you think does it take us to roll out the application at scale so we can go in production and become billionaires?
Well, you've gone through the security review, right, on the architecture review board, and
I think so.
Yeah, I think so. We can schedule a maintenance window in a month or so.
All right. And, so, okay, so a couple years down the road, and I'm all done. Excellent. Anything left?
Well, there was this OpenSSL issue.
No, wait, that's 10 years in the future.
And you know, there was this OpenSSL, so you know, I think we need to update all your stacks before we roll them out.
Yeah, but that's infrastructure.
But there's good news actually. We're getting this new version of RHEL. We're gonna just update the whole thing. You know, you think you can adapt your application to that?
Yeah, I can retest it, maybe rewrite half of it, and then figure out how to get rid of problems. That cannot be hard. All right. So I want to keep us on time here. So I think, as the role play indicated, that was not ideal. So let's see if we made some progress. A couple of years ago, we started to get all excited about virtualization, and ultimately we didn't like it as a buzzword, so we called it infrastructure as a service. Now, that obviously changed the world a little bit. suddenly provisioning of application became a lot faster because you no longer needed to order hardware first. But more importantly, application packaging could now happen in an isolated fashion by encapsulating the application and the runtime in a virtual machine image, right? That could be cloned around, copied around, live migrated, managed. Sounds all great. So let's maybe test that in our role play again. Here I am, the application owner. Daniel, I have a developer team standing by to start the new project. You know, the one that really makes us billionaires this time. And what do I have to do to get them going?
I think we have this new self-service portal, so you can just go select an image, build your stuff on it, and then deploy that in our internal Word cloud and start developing.
That sounds easy. That sounds really easy.
Yeah.
Okay, now
well, you have to, of course, make sure you are compliant with these management requirements. You have the agents there, right? And you know, make sure to have a process to get security updates into your virtual machine.
But that's infrastructure. You take care of
that.
No,
right? It's your virtual machine. Like, you know, I'll give you new images from time to time, but you know, you're in compliance now.
So you're saying, no, I own the infrastructure?
No, just your virtual machine, your application space. You know, I'll do the infrastructure.
Which is the infrastructure. Okay. So my developers tell me about this dependency, this library that they found, and they absolutely need it. So I can just inject this into my virtual machine?
Yeah, you can do that, or you know, we'll have a new image probably with that in a couple of weeks.
But we already have hundreds of images.
Yeah, well, you know, you can't have it both ways, right? Either you want a new library, or do you want to move all your old applications to this new library? We can do that, and you know,
all right, let me ask my development team if they really want this library. So now I've gone through all this. What about the rollout? How hard is it for me to roll this out at scale and go in production?
Well, you'll have to deal with the security team now. And
yeah, but we took your approved image from 6 months ago. That's still
have
fine,
you applied all the security fixes since then?
I'm sure we have not.
Well, you'll better talk to the security team if you don't get, and the architecture review board. Otherwise, I don't think we...
All right. Okay, I'll do all that. Am I good then? Anything else to consider?
I think you can just then, you know, deploy it to our cluster. Yeah.
All right.
Hardware's there, no problem.
Okay, good. All right, so my read on this is that's not ideal either. Gotten a bit better, but still not great. So what if we had something like this that we called application-centric packaging of applications, where effectively the application gets packaged together with all its dependencies, but only its dependencies, nothing else. And these packages can be deployed on an infrastructure that will run these packages, but is otherwise self-contained and can be managed at its own pace. That's what we enable with containers, and that's what is especially enabled with Docker as the technology to bringing the container to life. So in that world, the container image becomes the application with all its dependencies. The infrastructure is just the infrastructure. So let's test that in our fine role play again. So here I am again with my development team, billion-dollar application. It's actually $1 trillion now. So Daniel, what do I have to do to get my developers going with this?
Well, you just take our image.
What's that image?
Docker image that you can use. You build your stuff on it, and then create a new layer and hand it over, and we'll take care of it.
That sounds really simple. So what about if I have a custom dependency, such as a library that my developers want?
Well, you need to create a new layer for that.
So I can just change that image?
You add that to your image, and it's just, we can roll that into the next generation of the standard image if you want.
That sounds easy. Yeah. So, and if we want to go in production, what do? We take these container images and just throw it on your container infrastructure?
You still have to work with the security response team, but actually it's much easier. So we had this OpenSSL issue, and we already updated all the SSL endpoints. So,
all right.
Those containers are taken care of.
Sounds good.
There's no problem, and other than that, you just need to get it through the normal process. And
so what if there's another OpenSSL thing down the road?
Then that's a separate container. Don't worry.
All right.
You don't need to worry about that. And
that sounds good.
Monitoring is taken care of. No problem.
All right.
And you can take that image, and you can decide whether you want to use the OpenShift PaaS or you want to put it in the cloud. Once you build it as an image, we can just copy it around, no problem.
Wait, you're saying we can run this in our public cloud, private cloud, in the public cloud, or even in a PaaS environment?
You only need to build it once, yeah. That's fine.
All right, that sounds good. Okay. So are you basically saying that we could have something like this where the developer team, the application owner, just focuses and spends time on what they should own, which is the application and their dependencies, and the IT organization, the infrastructure, just focuses on infrastructure?
Pretty much.
That is awesome.
This is awesome. There's a good news, unicorns do exist.
You don't call them unicorns, though. All right. Daniel, why don't you tell us more about the technical detail?
Yeah, so I hope this was entertaining. So what is this about? Containers and Docker are the big buzzwords, right? You heard that in the announcement, some earlier presentations today. So containers, Linux containers, Dan Waldron says they don't exist. So it's a combination of kernel features that actually we can control on a fine grain. We don't have to always apply all of them. It's namespaces, it's control groups, SSE Linux that we use. And they provide lightweight isolation for processes, file systems, namespaces, and networks. Docker is a toolchain that builds on top of containers, and it enables aggregate packaging of a container. It provides an API, a layering model, a distribution model. So what it does, it takes the content of a container and puts it into an image. Image is, I prefer package for it because it's not block level, but it's called an image now. So it bundles the application with the runtime, and then you can distribute that. Next slide.
Oh, sorry.
Put that down. So one big question that always comes up, like how does that relate to virtualization? From my point of view, it's generally orthogonal to each other. Virtualization provides vertical abstraction, virtualization, while we see containers are primarily as horizontal segmentation. So there's overlap, of course, especially in areas where virtualization has been used outside of its core sweet spot for application isolation. But we'll see most people actually, a common use case is going to be to run containers on top of virtualization. But if you're really just looking for application isolation, delegation, or you want high density, you're going to run it on bare metal. So overlap, there's going to be a change from people using virtualization today, but it's not going away, or it's not a complete conflict. And I'm a real artist, as you can see. So one key concept in the Docker world, and that there were other people who tried to do something with container packaging or imaging, but what really made this work is the introduction of a concept of layering. So you start with a base image, and you can then specialize the image or expand the image by adding in a differential layer on top. Now, from the user point of view, if you use a container, you see the complete image. But from an operational point of view, that's a very efficient way. It's very dynamic, very agile, because you can add a layer, take it away, redeploy. And it gives you the ability to start with a very small generic image and then specialize in a inheritance model. And that's what allows this to actually become a general purpose packaging model that's not only used in-house, where you create your own images. We as Red Hat can provide images. We can have an ISV, create layers on top of that, hand them over to you as a customer, and then you can create your own customization on top of that. And in practice, this button is a bit, in practice, it really, is a chain like you see here on the right side, where we start with a base image, and then we're going to do a broader platform image. Then, like in this example, a HTTP. Then we add some LAMP stuff, and then there's an ISV application, and then your customization as a customer. It allows for the appification of enterprise, because it gives you a very easy to deploy aggregate model where you don't have to deal with the complication of putting all the pieces together, which takes a lot of time nowadays. Anyone who ever installed OpenStack knows how painful that can be. And at the same time, it still gives you the ability to overlay it with your own internal customization. And then with part of the Docker stack is a concept of registries and indexes and a distribution model. So it comes with an efficient way to distribute these images and manage them across multiple machines. And that provides a portability between bare metal machines. So the package you build, you can deploy on your bare metal machine, you can deploy it into virtualization, you can deploy it into the cloud if you have a host operating system or layer that provides the container enablement.
All right, yeah, let me take over. So this morning we announced, and Paul touched on it in the keynote, but this morning we announced the Project Atomic and Red Hat Enterprise Linux Atomic Host as a future variant of RHEL 7 that we bring to market. Now, RHEL Atomic Host is really designed and optimized to serve as a container host. So everything Daniel was talking about containers, containerized applications, they need an infrastructure that is not only functional to run a container, but that's also optimized in a number of ways. One of them is to enable our role play, we really have to get the footprint down to the essential minimum of what's needed to just take a lot of work and patching and change, but also technical risk out of the equation. So RHEL Atomic Host is going to be, first and foremost, RHEL. It's a RHEL variant built from the RHEL packages, build sources. Think of it as a variant that's just delivered differently. It's going to be very small. And the second set of attributes are really about optimizing for the container use case so that you can actually declare for an application, let's say you have a typical web type application with some web front end, a couple Apaches, you have some memcached, you have some persistence layer somewhere. We have a fantastic demo on the show floor with MongoDB and also at the various Red Hat stands where you can actually see how easy it is to take such an orchestrated application and do the container wiring at the host level by specifying which port coming into the host needs to be mapped to which port in which container. How do container instances have to interact with each other? This is what we call container wiring and orchestration, and RHEL Atomic will have all these capabilities. On the minimal footprint side, what is also very important for the container host, we really want to take as much technical risk out of the infrastructure as we can. So RHEL Atomic will have atomic updating that allows you to not only update it at once as an incremental step, but if anything went wrong with that update, you just get rolled back to the latest working state. So you don't actually have to worry much about that. While Daniel's getting the clicker, just on the project side, because we don't have a slide on this here, and we got tons of questions already on Twitter today. The Project Atomic is going to work in integrating all the many technologies that play together here. Docker as an upstream, the various Linux container technologies that we talked about, SE-Linux, C groups, namespaces, but also good old technologies that we all know and use every day, like RPM and Yum. They obviously still have a role in here. They're feeding what gets into a container. We have to bring all these pieces together. Project Atomic is going to drive the collaboration, innovation around all these technologies, and then enable atomic versions of Linux distributions, such as a Fedora Atomic or a CentOS Atomic, and ultimately RHEL Atomic Host.
So in more detail, and all of this you can also do with a good old RHEL machine. So you can install RHEL, and it's going to have Docker support available. And everything we see here you can do. This is simply an optimized version of it, variant of it, based on the same code that's available in RHEL, with the difference that Lars alluded to, which is the atomic update, which you're not going to run Yum on the host. You're actually going to use OS tree to update the host it's not really an image, it's a tree sync with kind of a rollback functionality. So you can deploy that as like an image, but it's it's a different view on the same thing, which is a bit more flexible. The atomic host will run on bare metal or virtualized, and we'll have cloud images available for that. which gives you an additional control point. So today, if you want to deploy an image you built in-house into the cloud, you basically have to put it through the infrastructure cloud management environment, like create an AMI, for example, for your stuff. With this, you have a generic atomic image, and then you can deploy exactly the same binary container image that you deployed in-house. You can deploy that on the cloud with the same command line. So it gives an abstraction layer for aggregate package deployment. The host, the standardized host will provide the core container functionality. It will provide systemd for process management. We'll have orchestration primitives in there, and Docker as the tool to manage the container images and instantiate containers. And one important point is, so the image itself, you don't extend this by installing additional RPMs like a normal RHEL variant. So the way to get images, to get agents and extensions to the host deployed is actually you deploy containers. Now that's a concept that you need to get used to. It's important to keep in mind here that in the container world, we do not have a hard barrier between the host and the guest like we have in virtualization. Right? The host can always introspect into the container. Because of the namespaces, the process IDs might look different and things like that, but the host can look into the container. And because containers are actually a number of fine-grained features that we can control on a fine-grained level, we can actually give individual containers higher privileges. So they're going to be privileged containers for shared services and management functions and extensions of the environment. So for example, bless you, for example, SSH is a good example. SSH is going to be a service, a shared service provided by the environment that you don't have to have in each container. That enables the concept of minimal packaging, which is really important. In our little role play, we got to the OpenSSL problem, right? If you have OpenSSL in your container, you'll have to rebuild the container and redeploy it to apply that fix. But if you treat your SSL endpoint as a shared service, as a separate container, you only have to touch those, and you're much more flexible. You don't have to touch your application environment. Which, so the separation into optimized container images for your application is really important as a concept. You don't have to do it. You can have at least eventually a multi-service container that looks a little bit more like a lightweight VM, but that's not the sweet spot. Now, so shared services, SSH, SSL endpoint, that kind of stuff. We'll have identity services integrated with IPA, systems management services, monitoring services. It's actually a big new thing for us. We have with Cockpit. We are starting. I think we have announced here in the summit.
No, Fedora, right?
Oh, it's Fedora. Fedora thing. So Cockpit is like a graphical UI for server management. New thing for Red Hat. It's really a big thing.
Good looking.
It's really good looking. Yeah. So. And that is shared service too. So you'll have these shared services, and they can actually operate on groups of containers, right? So you have the ability to group it. So you don't have to have one version of SSH for all your containers. You can have multiple versions for groups of containers. So real multi-tenancy. It's by default a multi-instance, multi-version, multi-tenant environment. The containers, the application containers, and that we built in a previous slide, they are deployed in here. One important piece is that they don't have to be the same version of RHEL, right? So Atomic will be based on RHEL 7, but you can use a RHEL 6 user space in there to package your application. So you decouple the runtime environment from the host, not only in the packaging and deployment model, but also in the versioning. So at this point, we are working on RHEL 6 support and on top of RHEL 7 there as well. Now, one other thing I want to point out is geared. So geared is an orchestration layer that comes from OpenShift. It provides kind of the basic clustering and cross-host wiring. So by default, atomic host will be clusterable. The cluster is the computer kind of approach, where the environment actually spans multiple machines, and they wire containers together if you have dependencies, things like that. That's going to be provided by geared as a layer. Bigger picture. This will be provided on top of OpenShift. OpenShift is an implementation. We are working on OpenStack integration, and this looks like OpenStack is running on REF. That's not really what this is supposed to mean, right? So REF, our enterprise virtualization, is going to enable Docker as well. And on the content management side, Red Hat Network Satellite will be extended to support the deployment of Docker images and the content management for Docker images. So out of satellite, you'll be able to manage your own images, which is going to be important because you'll have to rebuild them to apply fixes or add new layers to apply fixes.
All right. So to basically summarize to this point, what we get out of the deal, out of containerization of the platform, is really the combination of the fine-grained, lightweight isolation that we have in the Linux kernel with image-based deployment that, again, is lightweight and versioned in itself by using Docker as a supported format. And that is really net new. On the benefit side, we actually believe that this is fairly disruptive. And we're not announcing the end of something. We are here to talk about the beginning of something. I think we'll spend the next couple of years in really shaping that vision, delivering a lot of innovation and value to how IT works. We not only get all the deployment flexibility and the operational flexibility that we talked about, but the maintenance gets simplified by an order of magnitude or worse. And that is really, if you look at where cost is spent today in IT and where time to market is either achieved or not in getting innovation out of the door, it unfortunately isn't that maintenance very much. And at the same time, all of this together leads to lower cost, which again frees up resources to hire more developers, maybe more kernel developers who can help us on all that. But here's a couple buts, right? So far that all sounds great. There are a couple things that we still have to work through as Red Hat, as a community, and as an industry. There is obviously the question of application compatibility. Daniel mentioned we are absolutely intending to enable RHEL 6 applications to be deployed on a RHEL 7 host. And there might be other combinations somewhere down the road that make sense and are manageable from the technology. But just because we package a bunch of files into a container of sorts, it doesn't mean it will magically run anywhere. All these pieces will continue to evolve, have their own roadmap, add features, add dependencies, and potential known inefficiencies or incompatibilities. So we address this by announcing a certification program that we'll talk about a little bit more. There's another question, which was on Daniel's slide just before. There were little arrows on the top going into the content management of the host. So yes, you can, an application container image can be easily distributed, copied around, can be shared. In fact, Docker, the company Docker, is hosting an index with, I think, thousands of images in there, and all of them are available to be pulled down and deployed and operated. So there are some couple other interesting questions coming out. How can you actually trust, where a container comes from and what is in it? It's easy to consume some code from somewhere, but if you don't know what's in there, if you don't know if Heartbleed is maybe in there, you might not want to use it in the first place, right? That sort of thing. So we will work on providing the provenance and the level of trust, and that's, of course, something that we know very well how to do as Red Hat, because that's what we have been doing with open source and the whole ecosystem of solutions around RHEL for 10 years. There's a question of tools. Right now, the tools are nice and easy and smooth and easy to use, but it's also an early stage on the technology, so there's a lot of opportunity to provide rich management tools and workflows and really integrate it with our portfolio. Daniel hinted at our plans to do this within the Red Hat portfolio, and we will work with all our partners of creating compelling solutions in order to lower the skills barrier. I think there will be a lot of head spinning over the next couple of years when people realize not only that this technology is good for them and how they would use it, but actually how they would use it best because it will change how we think of applications. When today applications are delivered as one big blob VM image that you can maybe run on Amazon Web Services or on your private cloud, in the future that big blob is probably getting decomposed into 4, 5, 6 different containers that you will then orchestrate and wire together more intelligently. And this is how you get elasticity, and this is how you get flexibility to rev and innovate on each of those pieces. And then ultimately there's the ecosystem in which we will have to drive a distinction between something that is proven to work, is supported with somebody standing behind, versus, yeah, it might work, which sometimes is good enough, but certainly in certain environments is not good enough. So we didn't just come up with this just for this summit. We've been working on containers for a long, long time. In fact, it really goes back all the way to when we introduced RHEL in the first place, but then especially the core technologies that OpenShift has been relying on, SE Linux and C groups, to provide that level of isolation, actually goes back quite a couple of years, as you can see on this chart. And so we are now at the point where all these things come together. We are at a point of convergence. And RHEL 7 will really take a lot of advantage of this. And it's not just RHEL 7. You will see that same innovation going into every offering in the RHEL portfolio. RHEL OpenStack platform will, of course, be containerized in some ways and will be able to run in host containers. Daniel mentioned management products such as Red Hat Enterprise Virtualization, Satellite. So we will have a lot of work down the road to truly deliver on the vision of a containerized infrastructure. One key aspect that got us very excited at Red Hat when we were starting to look into Docker as a technology is really application portability and the ability to move small chunks of bits around in what we call the open hybrid cloud. Application portability is a key goal, not only within RHEL and between RHEL 6 and RHEL 7, but think about RHEL. You can use this in your private cloud. You can use this in your public cloud. You can run it on bare metal, in virtualization. You have all these choices, and the application will work. Now we're extending that promise to OpenShift as a PaaS platform, as a PaaS solution. So a container built in OpenShift will be able to run on just a RHEL host and vice versa. So that enables new use cases and scenarios for how development teams and production environments can interact with each other. And again, there's a lot to be figured out on the way as we get more into the orchestration and wiring.
And one thing you'll see is also that Red Hat products will be delivered in this format. So going forward, we can't make promises which ones, but high on the list, what we want to try is Red Hat storage, for example. Where historically it used to be a software appliance, and one way to look at Docker images, they are kind of software appliance without the hassle. We had Red Hat storage as a software appliance based on RHEL 6.4. We wanted to co-host it with OpenStack Nova, which is based on 6.5 in the current version. Doesn't work. Right?
So before you write in the press about us Dockerizing Red Hat storage, please give us a couple minutes. We haven't told them yet. So,
but it's just an example, and we can't, make any commitment. But
no commitments yet. Correct. Thank you.
You'll see us using this because it actually makes our life easier. So a lot of the enthusiasm that you see, on the Red Hat side around Docker is because we see it solving our own problems as an ISV to RHEL. And where we have software that's built on top of RHEL, this actually makes things easier.
Right. Okay. So I already mentioned it, the container certification. That is something that we announced just a couple of weeks ago. And that was really to state an intent, but also to get engaged with ISVs. We actually believe that containerization fundamentally solves many of the technology delivery challenges that ISVs have today, because they're all challenged with a really, really hard question. In order to participate in an infrastructure as a service world or in a hybrid cloud world, they will have to interact differently with an operating system or a runtime stack underneath their application. And most ISVs are either not willing to do this or they're not well prepared to do this. They're not the experts on things like Heartbleed and how do you manage these kind of changes and roll them out. Containerization gives us a complete new shot at how an ISV can deliver value to the enterprise or to his customers, and at the same time also creates new opportunities for ISVs and customers to interact with each other. So the certification program that we're working on is going to attest a level of compatibility and a support promise throughout the entire stack. from the application itself to the runtime. We already have that today. It's called the Red Hat ISV certification. We're expanding this to now attest that the application delivered in a Docker container format is playing by Red Hat standards and Red Hat rules. So we can make sure that whatever contents in that image can be trusted. And we're extending the compatibility promise from the actual container image and its content down to the container host and infrastructure, which is where we get into RHEL, OpenShift as the primary choices today. And again, what it leverages are the deployment choices that are sitting underneath that are already certified with thousands of certified hardware devices or products, as well as certified cloud providers and environments, as well as hypervisor and virtualization environments. So to maybe wrap up the benefits section, as you might have noticed, we're really excited about this stuff. And I'm quite sure it is really a big deal once we have it out, once you have it in your hands, which you will have to wait a little bit longer. We announced today that there will be a RHEL 7 release candidate available to all of you next week. This will not yet include all the container technologies, especially the Docker. We're still working upstream through some heavyweight changes, so that's not quite there yet, but we do plan to land this near the RHEL 7 timeframe. We are going to extend the existing high-touch beta program. So if you are in this program, then reach out, ping us. If you want to participate there, then just let us know through that program. If you're not in that program, then just contact your Red Hat representative to see if we can make that happen. But just to wrap up on the benefits, it really comes down to, it is about portable application deployments. It's about applications moving in the open hybrid cloud and enabling as much deployment choice and flexibility as any of you needs. It is about efficiency. It's about efficiency in the initial delivery. It's about efficiency in patching and maintenance. It's about organizational efficiency. Most organizations are just not able to become DevOps overnight because they have skill sets, they have tools, they have processes. We believe through containerization, you can actually get there by just redefining how you work together, because now there is a clear boundary between the output of one team becoming the input of another team. We actually think this is big. This is really a big deal. And it's about speed. I mean, we talk about agility. We talk about the promise of cloud and big data. This takes down the time it takes to get something created, get something copied, get something deployed, updated. We don't talk weeks, we don't talk days, we don't talk hours. We probably talk seconds in most cases, because we have lightweight chunks of bits that we can even move around incrementally. This is going to be very impactful. And while we do all this, we can still leverage all the things that RHEL stands for. It's going to be reliable, it's going to be mission critical, it's going to be secure. You will have isolation between these applications, at least as good as virtualization, probably better, because we have more things that we can separate and manage. And at the same time, we enable sharing and fine-grained control over who does what, where, what is an application allowed to do. That's what you see in all these Red Hat technologies that we spent many, many summits talking about coming together. With that, we would like to point you to additional references. There's a bunch more sessions tomorrow about containers. So check it in your agenda in both the Red Hat Summit as well as the Dev Nation. And they go to varying degrees of technical detail and depth. We have some really cool demos prepared on the show floor and the partner pavilion. So please have a look, talk to people, talk to us. Don't look for container logo. I figured that on the booth it mostly talks about RHEL 7 and things. So don't just look for the word container.
There's one
that
actually has containers.
Yep.
In the emergent technologies.
So don't build a long queue around this one booth. There are other parts where we show the same thing. And there's even a lab tomorrow afternoon.
Which is sold out, but.
So some of maybe the lucky ones of you, you have it. With that, I would like to spend the remaining time, we still have a bit of time, to handle a couple of questions. So you are able to ask us questions via this fancy app, and I get it on this fancy iPad, and then I can choose to ignore some questions that I don't like. How is that? So while you do that, let me read you what we've got so far, and then we can maybe still walk around with the microphone. Where's the borderline between Docker and Puppet configuration management?
That's an excellent question. So we have to talk to Puppet about that a bit. But my view would be that, so first of all, mean, yes, you can use containers for specialization, and you will be able to get more special, make your specialization more generic in the packaging through building layers. So there is, again, an overlap with things today. You use configuration management and deployment tools and provisioning tools, not only Puppet, but all kinds of other things. In the Red Hat world, also kickstart files to some degree, to capture things that in the future you can actually capture in your Docker file and build in the package. However, you don't want to put all your configuration in that, because at the end, that will lead to too many images, right? So you want to make the images generic for your organization, and then still use configuration management tools and other parameterization models to deploy the configuration. How that really plays out will depend on the kind of pet versus kettle character of your application. There is no, there are people who say Docker is more for the kettle. That actually is not the whole story. You can use that for all kinds of workloads, and then you'll use things like Puppet to actually manage that. Now, the Puppet agent itself, and that's an interesting, going back to the advantages sometimes over other models, I would not imagine to end up with a Puppet agent in each container. What you want to do is treat it as a shared service again, to operate on a group of containers. And that's the part where we actually, we are looking forward to see the open source model work, to get that to be a real nice solution, to work in this atomic concept, where we have a clear idea how the interaction between the shared service Puppet and the individual containers work, and how it operates on the containers with which privileges and this kind of stuff.
All right. Good answer. Very short and crisp.
Did someone, we should have taken time, who talks more?
I'm sure somebody did. Okay, next question is, taking that OpenShift upstream is working on Docker replacement for gears and cartridges. Can I take a Docker container from OpenShift origin and deploy it on OpenStack, RHEL Atomic, RHEL 7? So the answer is going to be, as I read the question, maybe. Because it combines, and let me explain that. Because the question is about OpenShift origin, which is a community project. It doesn't specify which payload goes into the container at all. And then it talks about deploying it on OpenStack, RHEL Atomic, RHEL 7. So as I explained on the certification program, we have at Red Hat, we've spent the last 10 years of building a fairly clear and easy to understand line between what Red Hat supports. Red Hat supports products, and Red Hat innovates in projects. And that's not going to change because of containerization. So in order to be supported on a product, you need to either have a supported runtime and then a certified stack throughout, or if you walk away from that, then you probably lose quite a bit of that support value. It's as simple as that. So we will make that easy, and in fact, we're still working on the tools to make that easy, so for anyone to know if something is in fact supported on a particular destination, depending on what the payload was. We anticipate today that we can make the Docker format ubiquitous, stable, and interoperable across all kinds of communities, products, portfolios. And that's also something we work on with Docker, the company, as we just announced this morning. You might have seen a press release about deepened collaboration. But in order to be fully within the promise of what will work, it's going to be a world of known and certified configurations. So that's the answer to that question.
Now, it was very crisp too.
Thank you.
Perhaps to underline that, if within the confine of having something that works on one, it will be portable. So if you have you build one package for your OpenShift deployment, you can deploy it on the others. Of course, in OpenShift, you get then the auto-scaling, things like that, which you won't get if you deploy it on RHEL. That's the difference at the end. But yes, the one package itself will work.
All right.
Lars said that, but...
now you heard it twice. So next question. all Docker images use the same IP or network adapter, or does this play into the virtual switch coming in RHEL 7? Couple things.
So the answer is depends.
Seems to be a universal answer to everything, and I thought that was 42. So maybe let me go first, and then Daniel can enhance it, as I'm sure he will. So we have to just, when we talk about networking, that's what we call this container wiring. So typically, what you do want to do is you want to be able to tell the host that you want this container to be available on this IP and port, basically. At the same time, you want to be able to declare that multiple containers need to communicate each other through whatever mechanism. And there are tons of ways to do that. Docker enables a number of these ways itself. So right now, from the way the technology stack is laid out, what we talked about today, and probably more throughout this week in Open vSwitch, especially, and SDN, that is really more like switching. That's kind of packet routing. I think that would be, for the most part, overkill in just container wiring. We will see how complex these environments go, and if we will need these capabilities. Right now, we can get a lot done with what RHEL Atomic, with the Docker support, does out of the box. The other caveat I want to mention, because maybe that was not exactly clear, Open vSwitch is clearly one of the key technologies we're working on for RHEL 7. But right now, we do not plan to deliver this in the RHEL server product, so it wouldn't be in RHEL 7 DVD ISO that you download. It's going to be available in the RHEL OSP offering and other offerings in the RHEL family that are then integrating this with whatever KVM, virtual machines, etc. So we're going to integrate these pieces. For the containerization right now, there might be somewhere down the road the need to truly have that capability at the host level, and if that turns out to be the case, we will make sure, we will figure out how to deliver that. But right now we don't see that.
So today containers don't virtualize the network. Right? You have namespaces for the network, but you share the same kind of network infrastructure. So it's the same routing table. Right?
That's a lot shorter answer. Thank you for that. All right, good. These were the questions with the sophisticated tools. Any questions in the more classical format with walking around with a microphone? And who does that? Any questions?
So the concept of a Docker image, is it actually a file that gets deployed for like the RPM runtime package?
So let me repeat the question before we answer, so everybody can hear it. So is the Docker file, no, what was it called? Docker image is like a file that could be copied around?
Is it like an RPM package, so it's a single file that can be deployed, or is it, again, yes. That depends. So in Docker, you usually operate on a repository that you manage using the Docker tool. It's inspired by Git. So you do Docker pull to get the repository that then has all the image layers. You can export that into a tar file, basically, and then copy it around. But usually what you're going to do, you're going to use the Docker command line to actually operate on these repositories. So you don't even have to deal with it.
So the answer is mostly yes.
Okay. So the reason I asked that is because at one point you pointed out one of the things to work on was verification or security of the images.
Yep.
So the question is, can you sign a Docker image? You will be able to. Right now, upstream, you can't do that, but it's being worked on. So it's obvious you need to be able to sign them to verify the chain of trust and things like that. There was a question back there. Performance is the question. Depends. So the performance, there are a couple of layers that come in. Of course, concepts like C groups, namespaces, SE links all have a performance cost. But it's much smaller than virtualization because it has to do less, right? It's pretty straightforward. There is also the way Docker works when you instantiate a container, it overlays the images. The way we do that in RHEL at this point is with DM-thin provisioning, which also has a performance overhead. However, usually your actual active data you would not have in your container image. You would mount it from the environment, right? The container, like if you update a container, you override it. So it's persistent. If you want to preserve it, you can commit it back into a container. or copy it out, but usually your persistent data would be mounted into the container from the outside. And there, so the performance there should be pretty good. The performance on the overlay is going to be lower if you keep things inside the container.
So to maybe also provide a different perspective to that question, the overhead is going to be minimal to moderate, depending on which mistake you make in how you use it. But there's another aspect that we haven't mentioned with a lot of detail, which is your applications are still running on a native kernel. So all the capabilities that a kernel brings to table in whatever NUMA balancing or whatever scheduling of resources, I mean, that's all still there. There's no overhead. Like in a virtualization, you'll do all these things twice, and that you pay for it twice. Yeah. So that obviously is not the case, and you can scale this also from very tiny little processes that just do one thing, like whatever a memcached, all the way to big heavyweight scale-up applications, because it's effectively interacting directly with the Linux kernel, right? That's another advantage where I think we get a lot of deployment at a very, very small price tag. There will be a price tag, but it's going to be very small.
And yeah, that's really the concept. Keep in mind, it's not an abstraction model like virtualization. You're really operating on the same machine. If you take away the Docker part, which is what makes this really nice and usable with the imaging and the aggregate packaging, the container piece itself you can do without that, and you can just run a process and put it into a context for isolation if you want to. It's not as nice, but people do that, and that's how OpenShift basically used to work before we had Docker.
Right. So there's another question coming in here through the sophisticated tool. Should databases be containerized?
Yes.
Hell yes.
Absolutely. But mount in your data from the outside. Otherwise, it's short-lived.
And your logs. Yeah, I mean, the answer is hell yes, because really there is no real penalty involved with that, and you get all the benefits of the deployment, updating, flexibility by taking advantage of this. Now, will ISVs jump on this right next week and have it available? Probably not all of them.
Our pilot, our prototype POC we are showing here is MongoDB. So
that's a good indicator. All right. Okay, good. So it seems like the beer has taken over some of the...
There's another question.
Yeah, I know.
And we're still in time.
Similar question about Java application.
Java?
Java application, yeah.
Why would you run Java applications? I'm joking.
So to defend him, he's an old Java guy. So absolutely. So actually, I can't say that. But
we are recorded, by the way.
Yeah, we are recorded. I can't say this what I was to say. But no, absolutely, like it absolutely makes sense. So actually, I had an example originally with EAP as a layering model. The problem is it was, I over-engineered a little bit, and so I went back to the web application stack. But absolutely, so on the Red Hat side, this is not a RHEL thing or an OpenShift thing. It's really across the product portfolio, and this does include middleware and Java. Yep. So we are working on having EAP and some other images available, and they will be available in the high-touch beta to try them out. From where I stand, one of the reasons why it's been a long fight in Red, like get Java to the Java guys to use RPM packages, and they didn't want to, and it took me a long time to understand that. But the way that Java is used, you want multi-version, multi-instance deployments, right? You want to be able to have different versions of the same Java stack. In different users at the same time on the same machine. And with RPM packaging, that's really not supported. Plus, you want to customize a lot, right? That's how most Java deployments work. You take something, you want to customize it, and RPM doesn't support that either. So actually, Docker works really nicely here because it gives you, with containers and the Docker packaging, it gives you the customization by just adding another layer, and out of the box, you get multi-instance and multi-version. You can run different versions at the same time and multiple instances.
So I guess maybe to look at it the other way, I think Docker specifically is especially well suited for file-based deployment methods. And the Java world happened to have picked up lots and lots of file-based deployment methods, whatever, ER here, war there, config file here. All this can now happen in a layer that sits on top of an otherwise defined container that then can be reused in many places. So that I think is great. Probably the transition is going to be harder for the RPM people amongst us because now that's going to be different. RPM is not exactly a file-based deployment method because it has all this dependency management built in that sometimes gets in the way. So I think that is actually a great way. It's not just innovating above and beyond what RPM used to do or did with YUM and all these things. It's actually creating a second path, and these technologies nicely complement each other. And I really don't see a category of applications for which encapsulating them in a containerized application package is not a good thing. I really couldn't think of anything. All right.
What is Docker Company's business model then? Above all,
I suggest you ask that to Docker the company. There are exhibitors on the floor, and I've seen they have a little pod there, and they're happy to talk to you about that. We have a partnership on the technology, as we've announced. We work with them very well. Has been a fantastic ride over the last couple of months. We've got a lot done, and we definitely look forward for Docker, the company, to be successful too. But at the same time, we appreciate that we're all good citizens in the open source community and we work together to deliver customer innovation. That's the right answer to that question. Other questions?
This.
what are your plans to basically manage large-scale deployment of Docker containers? Are you going to use satellite and cloud forms and other stuff that are they going to be integrated within the system?
All of it. So the question was, management of large-scale container deployments, are they going to be brought into the product? I think the answer is clearly yes, over time, right? I mean, it's not going to be like next week. The product that probably gives you the best container out of the experience, even today, would be OpenShift and OpenShift Enterprise, because as a PaaS solution that's heavily building on containers. Now, OpenShift is going to pick up Docker as a format and is enabling that support. So we'll see a lot of synergies going forward between these platforms. But in addition to that, as Daniel laid out, we had the big picture slide. There's a specific aspect of what we call content management. Like, here's your catalog of all the images, and here's who can change that, and here's where they're actually running. That's going to be a domain of satellite. But also the CloudForms product as a hybrid cloud management tool is actually going to be, I won't commit on their behalf, but we're actually fairly optimistic that we will have some container support in there, fairly simple, that initially mostly resembles virtual machines as a semantic, and over time then can be optimized for that.
And we're also working upstream in OpenStack to drive Docker adoption there, together with the rest of the community. But that's, for us, we don't want to end up with two worlds there, right? For us, it's a convergence. And we, in the spirit we had earlier, it's not going to replace virtualization. They're generally orthogonal, but there are areas where you would run it on bare metal or you would run it on virtualization, depending on what you need. And that makes sense even in tools that right now you think are in the domain of virtualization. So for OpenStack, I think it's a total no-brainer. We have to drive that forward, especially in the kettle use case. But even for Ref as a product, I think we'll see, at least we'll look at enabling that for Docker. There's no fundamental argument against that. So finally, we're out of time.
Yeah, one more question. One more question.
Okay.
Yeah, we got one more question. So bear with me, and then we can all have a beer together. So assuming shared services are key, it would be good practice to see the JVM as being a shared service. I would say yes, somewhat down the road. Initially, no, because JVM is in the execution path of applications, and therefore is part of what's getting started.
Right. Yeah. So you would generally, so everything that is loaded at runtime as a binary dependency ends up in the same container. The boundary is usually when you talk over the network or a socket to something, then you put that into a separate container, if you get it right. So the JVM is, you could think about containers like instead of being on the kernel ABI on a higher level, but that is much less generic. So now.
So the question, as I interpret it, is about a multi-tenant JVM interacting with the operating system through threads or processes, which then in turn take advantage of isolation. There are a couple pieces in that sentence that we don't have today, so that will take some time to get there. All right, good. With that, thanks for your attention. Thanks for staying with us that long.
And if you liked this, please fill out the form. If you didn't like it, don't
It's not a
bother.
form anymore. It's the new world. It's an app.
The app, yeah, sorry. It's still a form. It's just the...